Problem 6 gives the price of two ukuleles when they were bought, and then when they were sold in 1975 and 1995, and then 1980 and 1990. Then part A asks us to give a linear model relating the price of P to the Martin uke to the year T. Take T to be 0 in 1975. So basically all it's asking for is to create an equation of a line using those prices and selling points. So we know that it was sold for 900 and bought originally at 200. It was sold in 1995 and bought in 1975. So your slope is going to be 700 over 20 or 70 over 2 or 35. Then you plug your slope and one of the points into slope-intercept form. Y minus 200 equals 35 times x minus, instead of 1975, put 0 since t equals 0, and y would equal 35t for a number of years plus 200 for the line of the Martin ukes. For the Kanak line, or Kamaka, excuse me, do the same thing, find the slope using the points. We get 30 as the slope. Plug a slope and a point in slope-intercept, or slope point-slope form, and we get y equals 30t minus 50. Here we used x minus 5 since it was originally bought in 1980 and t is 0 in 1975. And then the question asks, at what point will one of the ukuleles be twice the value of the other? So you just set the, I think it's, yes, the Martin ukulele will be twice that of the Kamaka uke, and so you just multiply the equation for this times 2 and set it equal to the Martin uke's equation, and then you solve for t, and you get t equals 12, or 12 years after t equals 0, or 1987. Then it asks us to find a function that represents the ratio of the price between the Martin and the Kamaka over time. So it's really easy. You just put the equation of the Martin over the equation over the Kamaka, and that's it. That's your equation. Where it gets a little trickier is what it asks for is, in the long run, what will be the ratio of the prices of the ukes? And what that's saying is that as the number of years go by for an unforeseeable amount of time, I just used infinity, what will be the price? So normally when you have these kinds of questions, you get infinity is going to be in the denominator somewhere, which renders that ratio 0. It's going to be some value that's so small that it's all of a sudden insignificant. But the problem is infinity for t would just make this value very large. Now if you went ahead and put some absurdly large number in for t, let's say it was 1 million years later, you'd get our answer that I'll show you how to get in an easier way. But you get like basically some crazy value plus 200 and another crazy value minus 50. You end up with, you can see it, 7 over 6. But so the way we do this is we want to factor out a t. Since we don't have a t over here in this constant, what it's going to do is put t in the denominator. And when we factor out that t, we get 35 plus 200 over t. For the numerator and the denominator, we get t times 30 minus 50 over t. If you put an infinity here, just some really large number, infinitely large number, that becomes so insignificantly or so small that it can pretty much just go away. And what you're left over is t times 35 over t times 30. Now the t's would just cancel out, and you would get 35 over 30, which is how we got 7 over 6.